In this video we will be continuing our Coulomb's law. Now we have discussed that Coulomb's law F is equal to K Q1 Q2 upon R square. In last video I forgot to place a square on R, so the square on R will be also as a part of the formula. So this is what the formula of the Coulomb's law looks like. So now today in this video we will be talking about K. So K is known as Coulomb's constant. Okay. Now the formula of K, if we look at, so 1 upon 4 pi epsilon naught. We know that pi have a constant value, and epsilon naught, what is epsilon naught? So this sign, the curved E, is known as epsilon, and this dot is known as naught. So this sign is known as epsilon and this is known as naught. Okay, so what we call epsilon, actually this is known as permittivity of free space. Now what is permittivity of free space? Means free space permit the electrostatic force. Means free space allow the electrostatic force. So when free space will allow the electrostatic force, so now what will happen? So if we have a look at what's the epsilon naught value, so the value of epsilon naught is 8.85 into 10 to the power minus 12 coulomb Newton meter square upon coulomb square. How this came? This unit came Newton. We know that the unit of force. Meter is the unit of R, means distance, and as the square is placed over R, so R will become, and coulomb square. We know that coulomb, C is represented as a charge, so coulomb 1 coulomb 2 coulomb square. So this is what the permittivity of the space value, and this is the free, this is the constant. Means at the free space, at the free vacuum, the electrostatic force permit is known as epsilon naught, or the permittivity of space. So we'll have a look, what's the value of then K? What's the value of K? This is the formula of K, but then what's the value of K? So if we place 1, if we place the value of pi, if we place the value of epsilon naught, so we will find the value of K. K is equal to 9 multiplied by 9 power 9 Newton meter square upon coulomb square. So if we want to prove that how this square came, so K is equal to Q1 Q2 over R square. R is dividing over here, be going there, R multiplied by coulomb square, and this is multiplying over here, this will be going divide, and K. So we know that F is equal to N. R is distance, and what's the unit of distance? It is meter, and the square is also present here. Q1 coulomb 1 and coulomb 1 and coulomb 2 coulomb square. So this is the unit of K. Okay, as the value of K is also present and the unit of K is also being right. So if we place the value of K in this formula, so we'll have a formula this: F is equal to 1 upon 4 pi epsilon naught Q1 Q2 over R square. This is the whole formula. So when do we use this formula? We use this formula in the vacuum, when in free space, when the charges are in free space. Where is the free space? From earth to sun. from earth to sun there is a free space. Like we use this formula in the medium, like where the medium is not present. We know that air is a medium, so we uses the formula this for the air medium. But when there is no medium, means free space, so like from earth to sun, that formula, in that formula when the charge exists, we uses this formula. Okay.